In this video, we're going to talk about linear applications, and something to keep in mind when we're talking about linear applications, these are going to be applications in which we have a constant rate of change. So our rate of change that we're talking about in the problem will be the constant rate of change, which will also be our slope of the line. Okay, the next thing I want to mention is that when we're talking about an initial value in the context of a problem, we typically mean that to be the y-intercept, because we're not going to go to the left of the y-axis in most problems, because usually we don't talk about negative time. In most of these problems, we're talking about something over a period of time, and at the origin, that will be our starting point at 0 seconds or 0 years or 0 months. So that is going to be our starting point, would be our y-intercept. So the steps that we need to walk through to set up our application problem and go through the process of solving it, the first thing you should do is identify your variables. And you can do that by reading the question carefully and looking to see what two quantities are changing. Remember, rates of change and linear functions have two quantities that change with respect to each other. So you're looking to see what two things are changing. Okay, so in part 2, I want you to identify key values. The key values that we're going to use in order to derive or formulate our linear equation. Then once we list out our key values and we have them, then we can use those to create our equation. Then sometimes the problem will ask us to just create the equation and that will be the end of it. And then if that's the case, we can just stop at step number 3. However, if the question then additionally asks us to use the equation that we just came up with to solve a question or to solve a problem or answer a question, then we want to go ahead and do that in step 4. So use our equation to answer the question, if the question asks us to do that. And then, of course, in step 5, if we have to use our equation to answer a question or solve a problem, we want to check to make sure our answer makes sense with the rest of the problem. And we also want to make sure that we have our units labeled. Okay, so in example 1, let's read through the problem first, and then as we do that, we're going to identify the variables and the key values for steps 1 and 2. A town has an initial population of 75,000. So right there, whenever you see the word initial something, initial population, initial cases, number of cases, something like that, you want to underline that because that is going to be a key value. Now the question goes on to say it grows at a constant rate of 2,500 per year. So here's another key piece of information. When you see constant rate or rate of change, those are also key words that are going to give us important information to solve the problem. The question goes on to say, assume this trend continues linearly. There's another key word. Because the question specifically says linearly, we know that we're going to use one of these two forms, either slope-intercept form or point-slope form, to solve the equation, or to solve the problem. Now it says find the equation that models the population. So in this problem, it just says to find the equation. So we can stop at step number 3. So for step number 1, we're going to identify the variables. What is changing is the population over time. And in this problem, the time is given in years. So we have two variables here. We have time in years, and we have population. These are the two things that they're talking about changing. Now, how to identify what is x and what's and y? Here's a big clue. It gives us the constant rate. And we know that the constant rate, because we're dealing with a linear function, is going to be our slope. So the slope is going to be 2,500 people per year. We also know that the slope is the change in y over the change in x. So by giving us the rate, we can quickly identify what's y and what's x, because I can say, well, if this is the change in y, then the population is going to be my y, and the change in x is going to be my years, so x is going to be my time in years. Now, because they give us the initial population, that's our value of b. That's our initial value, which is our y-intercept. So that's 75,000. They also give us our m by telling us what the constant rate of change is. That's 2,500. Now, it also says in the problem that it's growing at 2,500 per year. So I want to make sure that that slope is positive. If the problem said it was decreasing at a rate of 2,500, I would want to make sure that I put a negative in front of that 2,500. So we have our m and our b. So the easier of the two equations to use would be this one, the y equals mx plus b. Literally all I have to do at this point is just plug in my m and my b and I'm done. So I have y is equal to 2,500 x plus 75,000. So there's our equation, and we've completely answered the question. We have our variables set up, and we have our equations. So now that we can, if the question asked us to go on further and asked us to find the population in a certain year, then we can now do that. Okay, in example 2, it said, consider the scenario, a town's population is decreasing, so there's a key word, decreasing at a constant rate. So that tells me right off the bat that my slope should be negative. It also tells me in 2010 the population was 7,500, and by 2012 the population had dropped to 5,300. Assume this trend continues linearly. This tells me that I'm going to use either y equals mx plus b, or y minus y1 is equal to m times x minus x1. And we're going to use that line, okay, then to predict the population in 2016. So this is a case where we're going to go past step 3. We're not only going to set up an equation, but then we're going to use it to answer a question. Okay, so again, my variables, what's changing is the population. And this is telling us it's changing with time, and the units for this is in years. So, if you also notice, they give us some information here. In 2010, the population was 7,500. So I'm going to pair those up. And then I'm also going to pair up in 2012, the population was 5,300. Because of the way that I'm writing down my ordered pair, I'm going to identify the year as x and the y as the population. So I'll call this x1, y1, x2, y2. So that means my years is going to be x, and my population is going to be y. Now, in order to use one of these two equations, I need to first find the slope. So I'm going to find the slope by taking my y2 minus my y1 over my x2 minus my x1. When I do that, when I take 5,300 minus 7,500, that's going to give me a negative 2,200. And when I take 2012 minus 2010, that's going to give me 2. When I reduce that, that gives me negative 1100. And this should be a decreasing slope because if you remember, the problem said that this is decreasing at a constant rate. So what does this mean? If I keep my 1 under there, that means every year, remember x is years, this means every year the population decreases by 1,100 people. Okay, so now I'm going to put all this information into one of my formulas. Since I don't have an initial value, but I do have a point, I'm going to use my point slope form. Okay, I'm going to put in my slope, which is negative 1100. I'm going to put in my y1, which is 7,500. And I'm going to put in my x1, which is 2010. Now, we've got our equation in point slope form. We're ready to go. Now we're going to answer the question, predict the population in 2016. Okay, so where do I put that 2016? Do I put it in for x or do I put it in for y? And this is why it's really good to identify your variables. I know that my x is the years, so I know that I'm going to put my 2016 in for x. When you do that, take a minute, pause the video, put in 2016 for x, and solve for y. When you do that, you get that y is 900 people. So I labeled my units, it's 900 people. And then also, to check to make sure that this makes sense with the problem, I know that since this is decreasing, and in 2010 the population was 7,500, that in the year 2016 I should definitely have less than 7,500, which 900 is less than that. So it makes sense with the problem. If, for example, I made a mistake and I got y is equal to 9,000 instead of 900 because I missed a decimal or something, then I would know that something's wrong because I should be decreasing, so I should have less than 7,500. So checking to make sure that your answer makes sense with the question and the problem and the situation of what the problem is telling you really helps identify if you've got the problem right or not. Okay, in example 3, it says the weight of a newborn is 7.5 pounds. The baby gained 1/2 pound a month of its first year. When did the baby weigh 9.7 pounds? So we're going to round to the nearest tenth of a month. Well, first we need to identify the variables. Now the baby's weight is changing per month. So we're going to have the weight in pounds as one variable, and time in months is going to be the other variable. Now, some information here that they give us. It says the weight of a newborn is 7.5 pounds. Now, even though the question didn't use the word initial there, we can assume that that's the baby's initial weight because it's the weight of when he was born. So 7.5 pounds would be our B. That's our initial weight. They also give us 1/2 pound per month. Even though the problem doesn't say rate of change or slope there, it's telling us how one quantity is changing with respect to the other. So it's saying that it's 1/2 pound for every month. And instead of writing it as a complex fraction, I like writing it out so we can see the units, but we can just leave it as 1/2. 1/2 divided by 1 is 1/2. Now I can use my slope to figure out which of these variables is going to be x and y. Since the slope is the change in y divided by the change in x, I know my y is going to be the pounds and my x is going to be the time in months, right? It's the change in y over the change in x. So I have my m and I have my b, so I can just use the mx plus b form of a line and plug right in and have my equation right away. So I have y is equal to a half. I'll leave it as 0.5 since the other values are in decimal form. I have 0.5x plus 7.5. Now, this is our equation, but the problem asks us to then use our equation to figure out when the baby will weigh 9.7 pounds. Okay, so when is giving us a hint. They want us to find the x, the time in months, because it's asking us for when, and they're giving us the pounds, 9.7 pounds. So I'm going to plug in 9.7 in for the y and solve for x. So I'm going to subtract 7.5 from both sides. So that's going to give me 2.2 is equal to 0.5x. When I divide both sides by x, I get 4.4. So my answer is going to be, don't forget your units, 4.4 months. That's when the baby's going to weigh about 9.7 pounds. In example 4, there was a typo. I apologize for that. I missed my 45. It should be 4,500 down here. The problem says the number of people afflicted with the common cold in winter months steadily decreased by 225 per year from 2005 to 2010. In 2005, there was 11,475 people that were afflicted. It says assume T is equal to 0 is in 2005. So T equals 0 represents 2005. So T is going to be the years after 2005. Okay, which means, for example, T would be 5 for 2010 because that's 5 years after 2005. Okay, now let's go back and identify the other variable. We have one variable, that's T, which is our independent. That's like our X, but we're using T instead of X. Now, what's changing here with respect to time is the number of people afflicted by the common cold. So, let's call that Y. That's the number of people with colds. Now, T equals 0 is our starting point, which means our initial value in 2005 is going to be 11,475 people. That's our B. Because the problem tells us we're starting at T is equal to 0 at 2005. That's our starting point. So B, the number of people that have colds then at our starting point is 11,475. Now, it also tells us that it's decreasing at a rate of 225 per year. That's our slope. Since it says decreasing, I want to make sure I put a negative there. It's negative 225 per year. So, I have my M and my B, so let's use MX plus B form. So here's my equation. Now the problem says, in what year will the output reach 4,500? Meaning, when will there only be 4,500 cases of the cold? So, it's asking us to find the year, which is our T. Actually, I should be using, let me fix this. Instead of using negative 225x, I should be consistent with the problem and use T since that's the variable they're asking us to use. So we want to find our value of T when the number of colds is 4,500. So I want to plug in 4,500 for Y and solve that for T. So I'm going to take 4,500 and I'm going to subtract 11,475 from both sides, and that's going to give me negative 225t is equal to negative 6975. And then I'm going to divide both sides by negative 225, and that's going to give me t is 31. But that's not our final answer. It wants to know what year. Remember, t is equal to 0 represents the year 2005. So if we're 31 years after 2005, that's going to be the year 2036. Because I take 2005 and I add 31 years after 2005. Okay, last example, it says for the following exercise, use the median home values in Mississippi and Hawaii, shown in the table below. Assume that the house values are changing linearly. So that's our key word so that we know that we have a constant slope. If these trends were to continue, what would be the median home value of Mississippi in 2010? So we want to look at Mississippi information. So we're going to look at these two columns. So I have the point 1950 and 24,600. And then I also have the point 2000 and 73,450. So these 2 points will help me find my slope. So I'm going to take the change in y over the change in x. So I'm going to take 73450 and subtract 24600. And my change in y is going to be 48850. Then I'm going to take my change in x. 2000 minus 1950 would be 50. So then I'm going to divide that by 50, and I'm going to get 977. And what does that mean again? Since this is my x, the years, and this is my y, the cost of a home or the value of a home, I know that, and this is positive, that means for every year, the price of the home is going up about $977. So now we have to use this information to figure out the home value in Mississippi for 2010. Okay, so if we let y equal, if we let x equals 0 be the year 1950, so x is going to be the number of years after 1950. That means my starting point at x equals 0, my value is going to be 24,600. That's going to be my initial value, my b. So I'm going to have the equation y is equal to 977x plus 24,600. So if we want to find the value of the house in Mississippi in 2010, that's going to be 60 years after our initial point. 1950 to 2000 would be 50, and then another 10 years, that would be 60 years, would be 2010. So I'm going to put in 60 years for x. And when I do that, I'm going to take 977 times 60 and then add the 24,600. That's going to give me a value of 83,220. Whoops. So that's my dollar amount for a home in Mississippi approximately in 2010.